Hi, can you hear me? Oh my goodness, network's so slow. What's going on? Why is it so slow? All right, anyway, whatever. All right, so let's see. We do have a midterm this week, right? At the end of the week. Hopefully we won't lose the network on Friday. The exam is on a laptop, so make sure to bring your laptop and it's fully charged, and they'll survive the whole class. It'll be the whole hour and a half. So the material will be up to whatever we saw last Friday. Okay, let me share my screen. Okay. So everything up to triggers, store procedures, not including anything that we did with Java. So that Java is definitely not going. Any coding on JDBC or getting a connection or logging in programmatically, that's not on the exam. But everything else should be there. I do have a couple of slides that I'd like to go over that are representative of types of questions you should expect. Let's see. Let's review. And also talk about a little bit the kind of the style of question and what to expect. There'll be quite a few questions on group by. Well, obviously some really trivial select statements, right? Just select, these fields from these tables. Some of them will be a single table, and some of them will be two tables where you have to do the join, right? And something you should expect is I'm going to follow a naming convention throughout all my questions, which is I'm going to any foreign key will have the same name as the primary key that it refers to, right? So that I don't have to say this field references this other field, right? And the names could be different, right? To simplify that, I'll follow the naming convention that if you see a foreign key, it'll have the same name as the primary key that it refers to. Okay, so some of the things that I try to throw you off when you see it like a join, where you have two tables that are being joined. One of the things that you should look for is are the primary key and foreign key, do they match, right? And one of the things that I might do to throw you off is I'll make a primary key equal to primary key, a foreign key equal to foreign key, which makes no sense. Yes. It's not published. Okay. Thank you. And so just one, that's something you should first check to see, make sure if there's a join, right? You can easily, if I give you 4 choices, you quickly verify that all the joins make sense. Yes. Or one of the typical things is that I might give you 2 tables, and for every 2 tables you need at least 1 join, right? So you should also check that and make sure that the number of tables makes sense with the number of joins. There's always 1 less join than as many tables as you'll have, right? Or I might give you too many tables, right? Or too few joins, right? And so that definitely it's a giveaway that there's something wrong with the question. Yes. Yes, the grade should be immediately. Nevertheless, even though the grading for us will be easier, it doesn't mean that if you feel that you put a comma in the wrong place or you misspelled something, certainly please let us know when you can look at the answers again. We'll make them available. Go look over if you think you misspelled something. We'll definitely revisit it and give you the credit. Okay. Yes.
Should the exam take the full 100 minutes?
Yeah. Yeah. Yes. I'm sorry. The answers to Q4. Yes. Let me do that right now. Yeah, so please review if you think it was a trivial mistake. We'll revisit and check it with you and give you the full credit. Right. So please take a look at that. Yeah. So just take a look at some examples. Obviously, you'll get for every topic there will be some trivial questions, some really easy ones. So some low-hanging fruit, right? So just simple select. There'll be a simple insert. There'll be a simple update, right? So those will be easy ones, right? And they'll get progressively more challenging, right? Certainly the first ones will be probably just a single table, and then 2 tables, and then 3 tables, right? And then well, there's joins in there, right? And whenever we have joins, make sure that all the primary keys and foreign keys match, right? So let's take a look at some of the these simple ones. That I think the more challenging ones are the group by questions. So I like to spend some time on that. So here we have a table called orders, right? We have 3 fields. And the questions might be something like, here's the type of question we're trying to answer, very much like the assignment, right? In the assignment we asked, what is the most popular blog, right? And that meant that you had to first calculate, some average, right? And then calculate, how much, what are the scores, and then is that greater than some average, right? And typically you have to create 1, 2, or 3 subqueries of which you can then combine to answer a bigger question, right? So here's just a simple answer, a simple question, right? It says, the sum of all orders per customer. So oftentimes whenever you see a per customer, that's kind of a giveaway that you're going to be grouping by, that field, right? And oftentimes whenever you see an aggregate function like a sum or count or how many, or averages, obviously there'll be some aggregate function in there, right? So this was pretty simple. It says consider following orders, customers, order date, and order price, and that's the question we want. And so the options might look something like this. I've highlighted here reasons why some of these answers are objectionable, right? And usually when you have 4 choices like this, there are 2 that are obviously wrong that you can really quickly just discount. And usually it'll be the last 2 will be almost identical to each other, right? And you have to go back and forth, see what's the difference. Why would be one better than the other? But let's see. So the question was the sum of all orders. So really, very quickly, you looked at the sum, right? You're looking for some aggregate functions, and they all have sum. So that's not what distinguishes them. Looks like they're all adding up the order price, right? And so it looks like they're all doing that. So that doesn't seem to be the issue that distinguishes any one of them. Then we might take a look at the group by, right? Per customer, that's kind of a giveaway that we want to group by the customer, right? We want to create a bucket for each customer, right? And put all the prices in each one of these buckets, and then add up how much the prices are for each one of these orders. And so we see that two of these are grouping by the order date, by the order date. So this one's by the order date, this one's by the order price, two by the customer, one by the order price, and the other one by order date. So this one's creating a bucket per date, right? So there might be many orders on the same date, right? And they would go in that bucket, right? But that's not what they want, right? It says they want it per customer. So we want the buckets to be customers, not dates, right? So definitely not this. This is by order price. So that means that we would be creating a bucket per price. So all the $10 price orders would be in the same bucket, right? And then you would be adding them, but that's not what they're asking for, right? So these two immediately by the group by, you can easily just discount them, right, altogether. The last two, they seem that they both are grouping by customer. This is kind of what we want, right? Creating the buckets by customer. They both have the aggregation, right? We both are aggregating by order price. That makes sense. And so the last part that we're considering is the select clause, right? The projection here. And if you remember, the only thing that could when you're grouping, the only thing that could possibly go in the projection clause, right, in the select clause, is things that you've grouped by, right, and things that you have aggregated, right? So aggregation functions and fields that you've grouped by, right? Of which this one breaks that, right, because we have the order date, right, and the order date is not in the group by, and it's not being aggregated. Okay, so definitely that's also why we're throwing this one out, and we're just leaving out with option A, right? And the reason you don't have the order date is that because you're creating a bucket per customer, there's going to be a whole bunch of dates in each one of the buckets, right? So you don't have a date, right? You would need to somehow aggregate them, or maybe min, max. That would be okay, right? If I had a min here, min order date or max order date, then that would be okay, right? So order date could be in there, right? But I can't just display all the orders. Yes, all the dates. Yeah, they're all very common that we've mentioned them. Average, sum, min, max. I'm not gonna ask you to remember them. They'll be obviously an aggregate function, but yes, they're counting, averaging, min, max, sum. So those are the most common ones. Yeah. Yes. I'm sorry. It's open book. Yes. Yeah, it's open book. So question 2. So again, another group by question. And just an example of the naming convention that I'm going to be using, right? All primary keys are going to have PK next to their names, right? So that's the primary key. If it's a compound key, right, I'll probably either just name them both PK, right, and they're compound, or I'll put them in in curly brackets as being a PK. Yes, right. But if you have two fields with PK next to them, you can assume that they're a compound key. And then you'll have the foreign key, right, with FK next to their name, right. I used to use bold and italic, and folks, it wasn't very clear on Canvas. So I'm now using this nomenclature of putting PK and FK. It looks like that's more clear now. Now this one has 2 tables, right? And the 2 tables notice that are related to each other, where the orders have a foreign key to the products, right? So you can have many orders for one product. So there's a one-to-many relationship. Now this schema could be that I give it to you this way, right? As a schema, right? With name of the tables and the fields, or I might give you in UML, right? I would give you two classes and then like a one-to-many, like one and then star and the other, right? And then give you the fields in there. So either way, right? I'll give you the schema. So the question is, how many orders per product? So again, right? It's saying that excuse me. It's kind of giving away the fact that you want to group them by the product. So you want to create a bucket for every product. You want to create a separate bucket, and then you're going to put all the records in each one of those buckets, right? And so how many? So basically, the product presumably is going to be either grouped by this primary key of the orders, right, or grouped by the foreign key PID, right? And perhaps we might need to join these two, right? When we might need to join where the foreign key of the order is equal to the primary key of the product. Yes, right? Not necessarily, right? Not necessarily do we need to join. Notice that it's not asking us anything about the product, right? It's not asking us, anything about the name of the product, right? Because the only information that the product table has is the name, right? If we're counting the number of orders, typically we're going to count, how many primary keys are in this order ID, right? So that's what we're going to be counting typically, the order ID. And if we're going to be grouping by the product, probably be grouping by product ID here in the orders table, right? Because since it's a one-to-many, one product has many orders, right? So we're going to be counting lots of orders for the same product, right? So they're going to be like 10 for product 1, 20 for product 2, and the different buckets, right? Whereas here, there's always going to be one primary key, one product, one primary key. There's nothing to count, right? So even though I might give you two tables, you might not need the two tables, depending on what I'm asking, right? If the question said something about the name of the product, then yes, I need to join the two, because that's the only way that I can go fetch the name of the product. Make sense? Okay. Okay. Although, would it make sense for me to ask the name of the product if I'm grouping by product, right? Remember the problem that if I'm not grouping by something, then I can't access it, right? Right. I can only access aggregations or the things that I'm grouping by, right? If I'm not grouping by the name, then I can't get the name, right? So you have to be careful there. So yeah. So we're all decided that we are going to be grouping by the orders product ID, right, by the foreign key. Right? So in each bucket, right, you're going to have 10 orders for product 1, 20 orders for product 2, and so on and so forth, right? And each one is going to be in a separate bucket. Looks like they're all grouping by order product ID, right? So there's no distinction between any of these ones, right? So we're looking to see where am I trying to trip you up over here. So let's see. Looks like the from clause, they're all using the same from clause, right? So from orders O, orders O, orders O, orders O. I saw some folks asking on the quiz, and they kind of were tripped up in this syntax. Remember, this syntax is a renaming of the table, right? So that you can refer to the table in the rest of the query using this alias. Yes. I saw that some people were asking on that on the quiz. I just want to make sure. All right, so looks like the from clause is the same on all of them. The group by is the same. So there must be something different in the select part, right? So let's take a look at the select. So it looks like we're always counting the order ID in all of them. So it looks like that's actually no. Over here we're counting the PID. See that? And the whereas in the other one we're counting the product ID. That's something different. So the problem of counting foreign keys, right? The problem with counting foreign keys is that some of them might be null, right? And so it might give you a wrong count, right? On something. So it's usually a bad idea to count foreign keys, right? Not always, but it might give you an undercount of whatever it is that we're counting. And so whereas in the other one, we're counting the primary key, which you can be guaranteed for it to actually have a value, a non-null value, right? So it's usually a good practice to count the primary key as opposed to the foreign key. Something else that I could have added here, is the product name, right? I could have added the product name, and that would be clearly wrong, right? Because I can put the product, I can put here I can put here the product ID, right? Because I'm grouping by the product ID, right? But I can't put anything else in here, right? Unless I group by it, right? Oh, something else that was wrong. Wait a minute. Group. Oh, okay, no, that's it. So yeah, you'll kind of see examples of that in the quiz where I will put fields there that cannot make it in there. Yes. No, actually, right. That's another issue here, right? Because there would be just one of them in each bucket, right? So there would be just one of those per bucket, right? So they will all say 1, 1, 1, 1 all the way through. Yeah. So here's another one, which is almost identical to the previous one, but it's using a different set of aggregates, min and max, right? The other one was doing a count, right? This one's doing a min and max. And again, we're being asked to consider two tables. There's a foreign key and a primary key, right? So here's the students and the major. Major is the primary key. Student ID also has a primary key, but the students has a foreign key, MID, right? Saying that this student, right, is currently enrolled in that particular major. Okay. And so it's asking us, what are the min and max graduation year? And the year, notice, is in the student table per major, right? And again, the major appears in two places. It appears as the primary key in the majors table, and it also appears as a foreign key in the students, right? So this kind of has the same kind of consideration we had earlier, right? That there's going to be lots of students for a given major, right? So we're going to have a per school, where every school will be its own bucket, right? The chemistry and electrical engineering and mechanical engineering and so on and so forth, right? It's going to have its own bucket, and there's going to be a whole bunch of students or records in each bucket. So that's what we're grouping by the major. And then what we want to do is that in those records that fall in those buckets, there's going to be lots of student IDs in there, dates of graduation, names of students, it's in there, right? Certain things we could aggregate, certain things we can't aggregate. Aggregating names would make no sense. Aggregating primary keys would make no sense, right? So typically we would do a aggregation, especially if it's min max, usually on some numerical value. In this case, would be a graduation year, right? So yeah, we want to iterate over all those years that are in each bucket, and find what the minimum and the maximum are, right? So let's take a look at some of the options. So let's see. So yeah, so we are going to try and group by the major, right? So we're looking for that. Let's see. The first one is grouping by the major, right? This second one is grouping by the year. That makes no sense, right? This would to say that if students are graduating in the same year, they would be in the same bucket. So that's not what we want, right? We want the buckets to be per college, not per year. So this one's definitely not not an option. This one too, right? Here, this one's also grouping by the year, right? That makes no sense either. But in addition, there's other couple things that are wrong. Even this would say, the correct grouping, it would still have something wrong because we are using aggregation functions in the where clause, right? We can't use aggregation function in the where clause since we haven't yet identified the records, right? You identify the records first in the where clause, right? And then you can do the aggregate, right? You can't have aggregation functions in the where clause because you haven't yet identified the records, right? So these would not be valid here. Notice that the select statement looks okay, right? Well, if we would be aggregating by the correct key, right? If we would be aggregating by the foreign key, this would be fine. The min and the max here are fine, right? Those are okay. But obviously we can't, that's not what we want over here. And the last one, we are grouping by the major ID. We are finding the max and the min, right? We are doing a join of the two tables. See that? We are joining the two tables because we are, for instance, notice over here, we are extracting the name of the major, right? Extracting the name of the major. And the only way to extract the name of the major is to join the two tables, right? Because the name of the major exists in the other table, not in the student table, right? So you need to navigate. So the joining looks okay, and that I would be able to extract it. But the problem is that this field is not in the group by. Right? It's not in the group by. So remember, there's only fields are in the group by can be in the select statement, right? So only this one, only this foreign key can be. This cannot be in here. It can be in the where clause, right? So because you want to aggregate or filter and identify which records you want to count, or min or max, right? But it cannot be in the select clause since you don't have that information anymore after you aggregate, right? The aggregations are fine, right? But this one clearly is wrong. So basically, you're just end up with the first one, right? Where you're grouping by the student. You have the min and the max, right? And the student's major ID, right? So it's again a yes.
If we want to include the major names, what would we change?
So for instance, you could find a value here, right? Which could be an inline view that's calculating something. And once you have that calculated value, then you can use it in an outer query, right? That you can then join this inner query with an outer query, right? That says, okay, well, what is the name of that college that has the minimum year, right? So now you can join it with the major table, right, of the year, and then say, okay, what's this one, right? And you can extract like we did in the lectures, right? We joined it again. What? Yes, exactly. Yep. Which is this question over here, right? This question over here, it's asking quite a few things, right? That where you have to do exactly that, right? You have to use a group by to calculate something, right? That you can then use as in an outer query, right? To join it with something else, right? So for instance, this one says, which students, okay? So this one's using the school database. So every year I choose a theme, right? Some years I've chosen the school database, other times like the airline database, stocks, right? So each year I choose a different theme. So this semester I used this database, which was a school database, department courses section, very much what we've been using so far. And it's asking us, which students, right? And notice when I say which students, I'm asking that for you to retrieve the ID, first name, last name, and final grade, right, for the student. Okay, and that information is available in the students table, right? And the students tables has the last, first, and whatnot. It's here, right? So which students got the highest grade in a course, So highest grade in a course. So that's something that we need to find out, right? Highest grade in a course titled CS 1234 in a semester of 2345. Yes. Yeah, it's like GPA. It should be like a final GPA. Not, it shouldn't be great. It should be like a overall GPA, assuming that you're only allowed to be in one particular major. Yeah, I shouldn't have said grade. This should be like GPA or something. So yeah. So which students got the highest grade in a course? So in a course, so highest grade in a course, right? So that means that if I had a whole bunch of courses, course 1, 2, 3, and so forth, right? Then in that course, I would need to put all the students that are in that course, right? And then some other students in some other course. It could be the same students, right? Same students in multiple courses, yes? And then for each one of those buckets, I need to ask, okay, well, I want to pick out which students got the highest grade in a course, right? And identify those students, right? It could be more than one. It could be more than one, and say, okay, well, let me find out which grade is highest, and then there could be multiple students who have that same grade. Yes. But then here they're making a little more explicit, saying that I don't really want every course. I only want a particular course whose name is CS 1234, right? And then so okay, well, okay, where and maybe that course is taught several times in the spring, in the fall, in the summer, right? The same course is taught several times. And there might be many sections, right, of that course. Notice that they're not asking about a section; they're asking about course. There might be 3, 4 sections per course, but they're asking us to take a look at the course, right, and across all sections. But then they're actually even more explicit, where they want a spring semester 2045, right? So it was first by course, and the course might be taught across multiple years, multiple semesters, but then they reduced it for a specific course and a specific semester. So definitely it'll be just one bucket at the end, right? So it's one bucket, that course, assuming that the course, right, it's unique, right? There's only one CS 1234 being taught at the university, right? You can have multiple sections, but there's only one of these, right? And that's unique. And it says, assume course titles are unique. So anyway, so let's see. So this is the schema that I would give you, right? And so notice that it says course title for CS 1234, and that information is available in the course table up there, right? And nowhere else. The semester part, the semester spring 2034, can be found, and the grade that the student got, right, is found in the enrollment table down there, right? So somehow I need to be able to relate courses with enrollments, and the only way to to relate these two is through the section table, right? Notice that you have a foreign key in the enrollments going out to the section, right? And you have a foreign key of the section going out to the course. So if I can have the title equal to CS 1234 and the semester equals 2345, right? I need to find out where do they intersect, right? Through the sections. Yes. Again, no, yeah, no. This would be like a GPA, like the overall. Well, presumably they are comparable in 0 to 100, the same scale. But yes, this would be like an aggregate, like a graduating grade. Yeah. But they have to be comparable, right? So they're all in the 0 4 scale or 0 100. Presumably you compare them, especially because they say which one's the highest, right? So we need to be able to compare them. So yes, they're in the same scale. So yeah, so we want to pick out which one are what is the highest grade, yes, and then there might be a whole bunch of students in that have the same grade in the same course. We want to compare them. Okay, what are the students that got that grade, the final in that particular course? So yeah, so let's take a look at these. Notice that each one of these right? So, which students got, so the students, that part needs to come from the student table, right? The first name, last name, because they asked for that, right? And then the highest grade, that means that there's going to be some kind of max something, right? Max on the grade of the enrollments, right? We're going to do some kind of maxing on this grade here, right? Somehow. And we're not going to want all the enrollments. We only want the enrollments that are somehow related to this course and are also for this particular semester, right? So we have to filter that out. Now, if we need to relate the enrollments with the courses, we'll need to relate them using the sections, right? The only way to get from the course title and the section, the enrollment, is through the sections table in between. Yeah, so let's take a look at some of the options. So let's take a look at this option here. So this was saying, this is saying, okay, well, notice that this is kind of has an outer select statement, right, where we are retrieving student information, right? Student ID, first name, last name, grade, student, blah blah blah, right? Where the grade is equal to some kind of inner query, okay? And they all seem to have the same structure, right? If you look at all of them, they seem to have the same structure. You have an outer select that is comparing some field with an inner select, yes, right? An inline view, right? It could, now in the exam, this could be an inner view like this, or it could be a literal view where I declare a view with this query, and then I use that view as part of this query. Yes.
It looks like students and sections are both being reading to S. Is that possible?
And where? Sorry. C. Oh yeah, they're local. They are local, and it's in the from clause. I'll try not to do that to not confuse you, but internally you can.
Okay, so that would be possible.
Yes.
And so,
Yep.
like the first line is from the student, but then.
Yeah, no, I would make sure that they would be distinct. Yeah. This totally can confuse you. Yes. Yeah. And so let's take a look at the first one. So the first one is selecting. Looks like it's selecting the information about the student. Fine. I mean, there doesn't seem to be anything problematic with that. Then internally, looks like they all are doing this max E grade, right? Which we were expecting that, right? That we are going to do want to find out, out of all the enrollments that are for this particular course in that particular semester, we want to know which one is the highest grade. Yes. So that looks right, and they all seem to be doing that, right? The max E grade. Right, so that looks to be correct, right? Now let's look at if we keep looking, we have in the from clause, in this particular one, we are, it looks like we're joining 4 tables, right? We're going from the enrollments to the section to the course. You remember there's a one-to-many from the enrollments to the section, and there's a one-to-many from the sections to the course, yes? So enrollments has a foreign key to the sections, and then section has a foreign key to the course, yes? So the joins, let's check out the joins, see if there's something wrong. It looks like I follow the naming convention correctly, right? The foreign key of the enrollment, the foreign key of the enrollment is equal to the primary key of the section, right? So it looks like that's okay. And then the foreign key of the course in the section table is equal to the primary key of the course ID. So that looks right, okay? And finally, the foreign key of the enrollment is equal to the student's primary key, right? So that looks right too. Right, so basically, I'm joining these 4 tables. These 4 tables, right? So foreign key of the enrollment goes out to the student, check. Right, the foreign key of the enrollment goes out to the primary key of the section, check. And from the section is going out to the course, check. Right. So the the joints look okay, right? And I have 4 tables and I have 3 joints, right? So that looks okay. Then you have here the filtering saying that I don't want all the enrollments, right? I only want the records for which the title of the course is CS1234 and the semester is 2345. Yes. So now I'm filtering all those courses, and I basically end up with just one single bucket, right? But then I get to the group by, right? And it looks like I'm not creating a single bucket. I'm actually creating a bucket per section, right? So all these records that I found are going to be, you know, for section 1 of course, whatever, course 1234 might have 3 sections, yes? Right, so, you know, course 1234, if it has 3 sections, there'll be 3 buckets, right? So it'll be a few records in bucket 1 for section 1, another couple in bucket number 2, section 2, and then bucket for section number 3. But that's not what we were asked. That's not what we were asked to do. We were asked to do highest grade in a particular course, right? So that's not what we were asked to do per section. We were asked to do per course, or at least there's no hint that we wanted it by section. Okay, so I would be, you know, discouraged to choose that answer. So let's take a look at a couple more. So how about this one? This one's saying so it looks like it has the same exact setup at the beginning, right? So the same analysis we did earlier applies to here, right? Looks like it has the same select. It looks like this has one less table that's being considered, right? So this one has the enrollments, the sections, and the course, but it doesn't have the student. And well, maybe I don't need the student. I don't know. Let's see. The joinings are fine, right? From the enrollment to the sections, and from the sections to the course, that looks okay. You know, I have 3 tables and I have 2 joins. That's good. And you know, you have to be careful, because sometimes I'll throw in you know, a deliberate, make it, you know, like the foreign key is equal to a foreign key, or primary key is equal to a primary key, or something like that, right? So you got to be careful. So always check your joins, because I might be trying to trick you in there, right? So just check those. The same filtering of the course, right? That particular course. Notice there's no group by. There's no group by. That means that whatever records this identifies, right? They're all in the same bucket. There's only one big bucket, right? And out of that bucket, right, I'm considering all the grades, all the grades in all the enrollment records that end up in this one big bucket, right? So this one does find out what is the max, right, for that particular course in that particular semester, that makes just one huge bucket, right? So I could have said group by course. Yes, I could have done that, and I would have end up with the same answer, right? I don't need to, since I know there's only one course in that one semester, right? So I'm not adding that. And so, okay, so it looks like that analysis could be applied to a couple others here. In number C, so we already dropped number 1. Answer B is a candidate, right? So let's keep it in mind. For C, let's see. So it looks like this one has one less table, right? Notice it has the enrollment and it has the section table. See that? It has the enrollment and the section table. It's not even considering the course table. So one of the questions might be, that's suspicious, right? Because we do need to filter by the title, right? We do need to filter by the title. So we do need the course, but we do have something like here that says course.title equals CS1234. So it looks like it wants to filter by the title. You know, whoever wrote this definitely knew that it had needed to filter by the title. But this courses is the name of the table, which is not in the from clause, right? So that's a syntax error. You can't do that. You can't reference a table unless it's in the from clause, right? So that's clearly trying to confuse you. So that immediately you can just consider that and just discard it. Yes.
The way you're finding the student's info is that you're the grade that they have in the students table to the max for the
Yes.
specific course.
Yeah.
What if there's like another student that had a different grade that was like the same exact grade?
Yeah, no, you would get all the students that have that grade. But this says equal, so there might be tons of students that had a whatever. Well, no, it would be for that course that we filtered out. Yeah. Oh, so you're yeah, we did not ask whether the student was in that had to be in that particular course. Yeah, but yes, we could do that as well, and then you would have to join more tables in there to make sure that that student is actually enrolled in that course. Yes.
So logically here, what we're saying is that a student has a grade which represents, I guess, the cumulative grade.
Cumulative, yeah. Yes. Right.
And then they also have a grade for this enrollment.
Yes.
And this enrollment has a grade for this class.
Right.
So then doesn't that mean that the student can only take this one class and the cumulative record for their grade is really only representative of this one class?
Right. That's because I named it as grade. It's misleading. That grade seems like it's the grade for that course, but the grade I meant it as a cumulative grade across all courses.
So what it's saying here,
Yeah.
though, is that S grade must be equal to the enrollment grade.
Yes.
Right.
Yeah.
But if S grade is supposed to represent the cumulative grade, then
Across.
how's that ever gonna happen? Like let's say I have a cumulative grade of a B in most of my classes.
Yeah.
This class is going to be slightly worse. I have a C.
Yeah.
In that situation, my cumulative grade is different from the class grade.
Right. And you would not be listed.
Okay. But
Yeah, this is only asking which ones got that grade. So you would have to get exactly that same grade. More reasonable would be something that you would ask, greater than or less than, whether you got the more than the average of that grade. Would be perhaps a little more sensible question. Also because in laws of averages, I'm not going to get exactly the same value as something that I might be calculating inside. Yes.
What if a student is doing the best in the class but doesn't have the highest overall grade because they're doing bad in other classes?
That's true. Then you would not be listed here.
You're asking for the best in the class. Right?
yeah.
The best in that one class. Yeah, so I would probably have to join a couple more things to filter out that student so that you're in that particular class or that particular course. Yes. Yes.
So that grade in the enrollment table, that is the grade for that student, that class, right? It's not the cumulative grade of that student.
Yeah, the problem if I take the grade as that meaning that, then I would need to have then it cannot live in the students table, right? It can't live in the student table. If it lives in the student table, it has to be an aggregate of everything across all the courses that you've ever taken. So that's why I was saying that it's a cumulative and not for that particular class. Right? Yes.
Questions asking for the highest grade in the course for that semester.
Yeah. Yeah, so that's why I'm saying that the left-hand side, right, you would need to do some additional joins with the course and the sections, which I didn't, and to filter out that I'm not considering all the students. I'm only considering only the students within that particular course in that particular semester, which I didn't on the left-hand side. Yeah. So this last one has the same problem as the previous one, right? Where we do need to do the joins between the courses section and the enrollment, and you do have here the mentioning of the name of the table, right? But the name of the table is not listed in the from clause, right? So this is a syntax error. So these last two have a syntax error, right? And they're discarded because such. So the only two left is between these two, and the first one we knew that makes no sense to group by the section, so we're basically just left with the number B. Yes.
Can you explain again why exactly you don't have a group by?
Because we're assuming that that particular course is unique, so giving a particular semester, that course will be only taught once, and so because of that assumption, right? And so you end up with the same one group. Yep. All right. So this one I'm leaving for you to play around with on your own. This one's a little more involved. It has several inlines instead of just one inline. It has a couple of inlines, right? And also it says that we're asking you to write this, but it's not that's not the case. In the exam, we won't ask you to write a query, right? You'll always be asked to either fill in the blanks for an existing query, or select from a multiple choice, right? So here's a query. It says, based on the airline database, which is very similar to the database we just looked at, right? Usually databases that I will give you are going to have a couple of one-to-many relationships. Like for instance, from the airline, there's a one-to-many for the flight, and there's a one-to-many from the flight to the reservation. Yes, right. And usually it'll be at least one many-to-many. Right? And in this case, we have the ticket is a many-to-many that relates reservations with passengers. So you might have a reservation that has many tickets in that same reservation, right? For multiple passengers, right? So one passenger can be many reservations, but one reservation can have many passengers, right? It might be a family that is traveling together, right? That's in the same reservation. And also, one airline can have many flights, and one flight can have a whole bunch of reservations, and one reservation can have many passengers. Okay, and so the ticket says that this passenger is in this reservation, right? It's a relationship between the two. And then you have this cuisine where that one food might be ordered by many passengers. So the question is, based on that database, write a SQL query to calculate how many reservations, right? So there'll be some kind of count, right? So there'll be a count of reservations, okay? Were made with Qatar Airways, right? So the name of the airline, the name of the airline is over here, right? Here's the name of the airline. We're going to count reservations, and there's a relationship between airlines and reservations, so which is joined by this flight. So there'll be some kind of join between the airline, the flight, and the reservation, right? And we're going to be counting reservations. So yeah, query, and how many reservations? So we're counting reservation.rid, yes? Where were made with the Qatar Airways, so the flight, the airline's name is Qatar, for a cost higher than the average cost for all Qatar reservations. So that's something we need to make an inline. So, well, what are the average costs for all reservations for Qatar? Right. So that's something you need to. That'd be some kind of inline where you're going to group by the reservations for the airlines of Qatar, right? And you're going to add up and do the average, whatever the cost is. Where the cost is defined as all the reservations, right, is the sum of all the prices of all the tickets, right? So given the reservations, you're going to have a whole bunch of tickets in that reservation, right? And each ticket has a cost. How much does that ticket cost for a given reservation? So you're going to group by reservations. There's going to be a whole bunch of tickets in there. And you're going to add that up, and going to calculate the average. So this is one inline, right? The average cost of reservations for the Qatar. That's one inline. They'll give you a single value, the average cost for Qatar Airlines, right? And that's going to be in the where clause. You're going to say greater than whatever that average is, right? In another inline, which is going to group by the reservations. Okay, so play around with this, and we'll give you the answer later this week, maybe tomorrow or Tuesday. Yeah, tomorrow. We'll give you the answer a little later, but play around with this first, and then we'll give you the answer a little later. Okay. All right, normalization. There'll definitely be several questions on normalization. And if you remember, most normalizations, we found out something that was wrong with the schema. I'll give you, we'll give you a schema, and we'll ask you what's wrong with the schema, right? And then ask you, what's a better alternative to the schema, right? How would you re-implement the schema to fix what's wrong with it? Well, first you have to identify what's wrong with it, and based on what's wrong with it, then there'll be a valid, better implementation. Okay. And if you remember, there's three normalizations that we consider, right? First normalization, second, and third. Yes. And the mantra of each one was saying that I think the first one said that all fields should be dependent on the key, right? And then the whole key and nothing but the key, right? So first, second, and third normal form, right? And so the first normal form basically looked to make sure that the fields, right, didn't have any repetitions in the field, right? That you didn't have anything like with commas separated values in fields. And usually the solution to any one of these normalization problems was that you would split that one table into multiple tables. Yes, right. They all have kind of like the same solution, right? Either one table into two tables or three even, right? To break the normalization problem. So yeah, so we would give you something like this, and then we would give you a couple of alternatives. Now this one's almost straight from the slides, right? That the field telephone has several comma separated values, and so we ask you what's a better solution to this, right? What's a better alternative? Should you have a new column for each one of the telephones, right? And one of the arguments against that was that, well, you don't really know how many telephones, right? You would have to add a new field, right? Every time you had a new telephone, right? Or the alternative is that you would just over engineer this and define maybe 10 fields, right? Hoping that that's enough. No one's going to have more than 10 phone numbers, right? And then you end up with a lot of very sparse tables with lots of nulls everywhere. So we definitely argued against that. Then we said, well, the other alternative would be to perhaps, for every new telephone, you would just clone other records, right? Where you have Alice in Wonderland would be repeated multiple times, so that you can have an additional record, right? An additional row where you can capture that extra phone, right? So again, we argued against this as well, saying that you're repeating all these values, right? Now you have redundancy. There's no way for you to enforce that this is actually the same thing, right? That you could easily modify one and make this inconsistent. So we argued against this as well, and so the conclusion was that the best thing you could do is to split this, right? Split it so that you would have the values listed only once, right? And then they would be related to the key in the other table, so that you would only capture the names only once. The phone numbers are only captured once, right? There's no redundancy, and then the relationship is what is how the records are related to one another. Yes. Yeah. So you could expect a question like this, right? The questions that you'll get are more generic. So they won't say telephones. They won't have first name, last name. They'll be random. So you'll see a lot of just random text, right? So, but other than that, it's very like this, very similar to this. Other examples that you'll find, other like the second normal form, third normal form. If you remember, each one was trying to fix something different, right? The second normal form was trying to dealt with with combined or compound keys. Yes. And the second form says, are the other fields somehow related to the whole key, or are they related to part of the key, right? Remember that? So for instance, in this case, you have the person here related to the combination of having won a particular tournament in a particular year. And it makes sense that the same person could have won it in 2 different years. Yes. So this is fine, right? That you have repetition here of Al having won it in 1998 and then won it again in 1999. That's totally fine, right? And now there's other fields that are not necessarily even related to the keys, right? They might be instead related to other fields in the same table, right? That have no dependencies on the keys, right? And that's one of the normalization problems, right? That there's no way for us to enforce that this value for that one person has to be the same, right, across multiple records. And there's no way for us to enforce this. Yeah, you could easily, by mistake, either misspell the name of the person or choose the wrong dates. Yes, and the database would not know that that's wrong. There's something wrong with that. So these dependencies between the fields, these functional dependencies with non-keys, is what we're trying to break, right? Not have. And the way we fix that typically is that we split it into other tables. Now, because the examples that you're going to see in the exam are going to be random, okay? So you'll have a whole bunch of random text here and a whole bunch of random text here, right? This one you can kind of logically, right? You can say, oh, well, this date obviously is referring to this field, right? Because this says winner and this says winner date of birth, right? But if this says XYZ and this says ABC, how do you know that they're related at all, right? So if the fields are related, right, and you have A here and B, and the values are related to one another, right? I'll typically, what I'll give you is a functional dependency. I'll say that A, B, something like that, right? Well, I'll say that the value of one is dependent on the other. Okay, so I explicitly say, and if there's other fields here with X and Y, right? I'll say X, Y gives you A, right? So where there's a functional dependency that if you know X and Y, then you know A, which is fine, right? You want the dependency of values dependent on the primary keys. That's okay, we want that. But we do not want dependencies between non-keys, right? We don't want this. This one's okay, we want that, right? We want fields to depend on the primary keys, not amongst each other, right? So if I'll give you this, again, because these fields will be just random, right? And you won't know. Yes?
So there would we know which one is the primary key? Like would you put primary?
Oh, I'll always say PK. Yeah, of course. Yes, of course. Yep. Yes. Yeah. So this one is dependent on the winner, right? Meaning that if you know the person, right, then you definitely know their birthday, right? It would make no sense that for the same person you would have a different date, right? So there's a dependency between these two, right? And the examples that I've used in class are things such as, if you know the model of a car, presumably you would also know its brand. If you know it's a Corolla, then you definitely know it's a Toyota, right? So there's a dependency between brands and models. Here, there's a dependency of birth dates and the person, right? If it's the same person, it would make no sense to have a different date of birth, right? It can only be that, right? So yeah, and we said that that we don't want functional dependencies between non-key fields, right? Because there's no way for us to enforce or detect that there's something wrong. And the fix usually is that this information should not be here in the first place. It should be in a different table where you have a list of all the people and their birth date, right? Only recorded once, right? Just captured only once. right? Such as this, something like this, where you have a list of all the folks, right? Chip and Al and Bob, with their dates, right? Now the birth dates are dependent on the primary key winner, and that's okay, right? We want that. We want that the dates are now dependent on the primary key of the winner, and then there would be some relationship between the winner referencing the this here. These would be foreign keys, right? These now would be foreign keys pointing to the primary keys over here, and then you can join these two to find what the dates are, right? Okay, so yeah, so that would be. I'll give you several options, right, of which you would choose, which one is a better solution of how to split this, right, and maintain the same data. Okay. Right. There'd be a question on relational algebra. You probably can expect exactly this question of definitions. Just what is select, what is project, what is sort, right? And they'll be kind of like match this with that, right? Or they might be split across multiple questions, where I might give you a sort or a select, and I give you 4 choices of what does select do, right? Of which only one of them is correct. So it could be either as a single thing. So this could be a reference for you, right? So that you know the definitions. I'm sorry? Yes, this is correct. Yes. That's a typo. Okay, so I should only show it once. Oh yeah, yeah. This was taken from when I was using Blackboard, and Blackboard broke my match question. Yeah. Other questions on using relational algebra will be using the two different syntax of writing expressions, either using the functions, the select functions, the project functions, all of those, and where the output of one can be the input of the other. Yes. Yeah. Yeah, I'll update it. Yes. Although in the original relational algebra slides, they're all listed there as well. But yeah, it'll be one place. Right. So the challenge of these types of questions is, is the output of one of them make sense to the input of the other, right? And also, if you remember in those slides, there were 3 ways of representing it. One was using these functions as the output of one function is the input of the other. The other one was using symbols, right? The pi and sigma and all those symbols. And the other one was using a tree, right? Where you had at the branches of the tree, you had the tables, right? And then the operations would operate on those tables, and then they would flow upwards, right, towards one single root, right? And the root was the result of that query. Yes, right. You should feel comfortable with all those 3 ways of representing it, right? And they're all equivalent with each other, right? But this is a functional syntax where the output of one function is the input of the outer function, right? It's so in this particular case, the project is it's taking as an input the table, right? And if you remember, project chose a column out of its input, whereas select chose rows, right? So project kind of like slices vertically, whereas select slices horizontally, and that allows you to identify exactly which piece of data you want, right, in this slice. So yeah, project is choosing a particular field, the name field, and so the output is the same employee table, except that only that one column, right? Only that one column. So that's what the input of the select statement is, right? The employee table, except that only the name column. But notice that the select statement takes 2 arguments, right? The table, the input data, plus a predicate, right? And that predicate is a filter of out which records match that predicate. Right? The problem with this query is that the predicate is filtering on the PID field, which is not in the input. See that? Right, this input only comes back with the name column. So I can't filter on that because I don't have that column, right, as the input. So the question was, what does this return? And the right answer is, so this query is meaningless, right? It doesn't return anything. It returns the empty set, right? Because there's nothing to nothing to compare it against, right? So, and then some other trick questions saying the names of the employees assigned to projects whose PID is 10 and so on and so forth, right? Make sense, right? You should be able to run the same type of query in an equivalent representation using the symbolic the symbols, right? Instead of using product or project, use pi. Instead of using select, use the sigma. And in the slides, it shows all the symbols that are in there. But it's just a different notation, but it means exactly the same thing, right? In this case, you have a select, right? And the predicate is the PID that is equal to 10 and hiring, right? So the PID is 10 and hiring years 2004, right? On the employees. So this one filters out all the records that meet this criteria. Once it identifies those records, it extracts the name, right? So it slices and only keeps the name field out of all those records. Okay. The alternative is also to use the tree. There's a tree version of this, right? Where you have the tables at the bottom and then the selects going out and the projection. So you should feel comfortable with that syntax as well. Joins. Yeah, so there'll be questions that are about joining tables, right? Either 2 tables or 3 tables. As opposed to just grouping, right? There'd be in the progression of the questions getting harder and harder. Group by will be towards the middle, towards the end, right? Usually you'll get some join questions first. So let's take a look at this. Notice that I'm following the notation of PK and FK, right? And so let's see. We have a portfolio with a portfolio ID. You have a stocks with a stock ID, and in the middle you have transactions that have 2 foreign keys, right? Which is the portfolio and the stock, right? And the amount, the number of stocks that you are purchasing or selling. And so this is a many-to-many, right? So in the middle you have this many-to-many pointing to either one. And again, this could be either in UML or using this notation, either way, right? So the question is to do a query, right, or select a query that retrieves all the technology stocks owned by John, right? And I remember a student's asking me, the technology stocks, how does that is represented here? It's the type, the stock type, right? Whether it's energy stock or technology stock or whatever, the type of the stock. And owned is in the portfolio, right? It's over here. So that means that some of the information lives in the stock table and some information lives in the portfolio table, right? And the only way to navigate between the two is to join with the middle table, right? With the transaction table. Yes. Apparently, yes. That's it. But you would need an owner table, right? A person table with a many-to-many or one-to-many with a portfolio table. Yeah. So the question is, okay, well, which one of these does this, right? And so definitely look again. Always look for some trick questions where I'm trying to trip you up, where I'll in the naming convention that I'm giving you, I'll make sure that the foreign key is equal to the primary key that they're referring to. So things like this, right, would make no sense, right? Where this is a primary key is equal to a primary key, right? If it's a foreign key primary key, then they have to have the same name, right? So that's a trick question. Careful. And also, you can make sure that if I'm not skipping over the relationship where I might do a stock is equal to a portfolio, which makes no sense, right? Because there's no relationship between portfolios and stock. You have to go through the transaction table, yes? So make sure that you check for that as well, right? Especially if you realize that this is a joining question, right? And just to make sure that you understand that it is between foreign keys and primary keys, right? And those joins, yes? Also, this is it's an implied join, right? Using this syntax of using just a where clause, but certainly you should expect using the join syntax, right? Where you say table join on, right, and some other table. So yeah, you should be able to read this either as an implied join or as an explicit join. Yes, both syntax. So yeah, so this one is immediately you can throw this away, right? So this makes no sense. This one is taking a look at the stock and the portfolio, but notice that it's skipping over the technology, the transaction table, right? It's not even joining anything, right? So this will return a cross product between these two tables, right? Only filtered by a particular type and a particular owner. But other than that, it's a cross product of these two tables. Yes, that's not what we want. So that's definitely goes away. This one looks like it's joining, right? Because we are going from the stock to the transaction and from the transaction to the portfolio, right? But this is a syntax error because I'm referring to a table that is not listed in the from clause, right? So that one is out as well. So that kind of leaves me the first one, right? Where just to check again, making sure that my primary keys and foreign keys are match, that I have listed all the three tables that I'm joining, right? And then the filter is okay, right? The type is what I was looking for, and that the owner is okay. Yes. All right, so just one last check. Here's another question, very, very similar to what we had earlier, right? Just a slightly different example. And we have passengers, reservations, and ticket. This was based on the airline database, right, that we saw earlier. And notice that the passenger and reservation have no relationship with one another other than going through the ticket table, right? The ticket table has the two foreign keys that refer to the person and refer to the ticket, right? So it has to go through there. Now, the question is that they want the names of senior passengers booked by Alex, right? And I remember one of the students asked me, what is a senior? Well, anyone who has a particular age, right? Age more than 65. And booked by Alex is the booking agent over here, right? So because we're asking, we're asking for the age of the passenger, well, that information is in the passenger table, and the booking agent is in the reservation table, and they're not related to one another, right? So we have to go through the mapping table, right? So we need to join all three, okay? As opposed to some of the examples earlier, right? That we were only being asked information that was in one of the tables. All the information was in one of the tables. There was no need to join with the other table, right? Even though I gave you two tables or three tables, just make sure that you actually need all three tables, right? I might not be asking you anything about a particular table, so you might not even need to join it, right? It might be a trick question, right? I give you too many tables that you only need just a few, okay? So again, just going through this, see if there's any trick here. So the first one is retrieving the name of the passenger from these three tables. Looks like they're all joining all three tables. It looks like the filter looks identical for all of them, right? We have the age of the passenger 65 for all of them. the booking agent is Alex for all of them, right? So that looks fine. The looks like in all of them we are naming all 3 tables, right? So that looks okay. So it must be that there's something wrong in the where clause, right? And so we need to focus on what's wrong with these, right? So right away we can see that it's kind of like a trick question here, right? That we're making primary keys with primary keys. That makes no sense, right? We want to, again, I will honor the fact that I will name all foreign keys equal to the primary keys. So that's an easy check for you right away. So that's wrong. That's wrong as well, right? So they're all wrong except with the first one having the foreign key of the transaction equal to the primary key of the person, and the foreign key of the reservation equal to the primary key of the reservation. Yes. Yeah. So sorry, the ticket, not transaction. And so again, it's a choice A. Triggers. There will be a triggers question, right? And the type of questions I was thinking of was something like, what I'm thinking is, well, here's what I was thinking. I guess I won't be able to use this example anymore, but it was something like, you have 2 accounts, right? And from an accounts table, yeah, you have like an accounts table, and then you have a transaction table, okay? And the transaction could be a deposit, right? A withdrawal, or transfer, right? And now if it's a transfer, that means that you need to update 2 accounts, right? It means that you need to withdraw from one account, right? And you have to deposit into the other account, right? So you have to subtract from one account and you have to increment the balance in another account. Make sense? So I was the question might be something like, create a trigger that if the transaction is transfer, then you're going to withdraw from one of the accounts and you're going to deposit into the other account. So that means that one insert one insert into the transaction table will cause 2 updates. Yes. So the trigger would do the 2 updates into the 2 accounts. Make sense? Right. It would update the balance of one of them, will subtract the amount, and the other one will increment the amount of the other balance table. Make sense? So that was a question that I was thinking. I guess I'll have to think of something similar to that, but not exactly that, but it will be something like that. All right. Where either inserting or updating one table causes an insert or update into 1 or 2 other tables. Make sense? Right. Yeah. So something like that. DAOs, that was about JDBC. So there are not, I'm not going to have any JDBC questions in this go around. Singleton pattern. If you want to take a look at them, I will not have them in this exam. All right, let's see what else. Yeah, that's all I have for you. Any questions? Yes. Yeah, right. I'll share that. And yes. Yes, there'll be some UML questions. Yep. Usually it'll be there'll be a piece of text, right? And then that text you'll be saying, which of the following UML diagrams matches that text, right? You'll say, you have I want a playlist of songs, right? And then I'll give you 2 classes, and I'll give you maybe a one-to-many, a many-to-many. I'll give you inheritance. I'll give you an aggregation. I'll give you a composition, and then you have to choose which ones matches. Yes.
Will we ask for the reified version for SQL specifically or no?
I will. There'll be a reify question, right, where I will give you a many-to-many, and then I'll ask you, how would you implement this in a relational database? Right. Also, there'll be obviously a create statement, something like that, where you have to fill in the blanks for a create statement. Yeah. Definitely. Yes.
How would you recommend studying?
I think I would go over all the quizzes. You should be able to do the quizzes just like that, real quick. Definitely the types of questions I have here, all the group by. I would play around with group by a lot. Says, well, let me create my own little thing and just group by this, group by that, and just practice group by. Yes.
There have been several times when we're taking quizzes and you ask whether or not we're done, and many of us are not. Is that assumption also going to be applied on the exam?
No, in the exam, you'll have the whole hour and a half, and I won't ask anything.
No, my question is rather like in terms of time.
Oh.
Because we tend to take longer than I guess you practice.
Uh-huh.
So
Yeah.
does that be considered when the exam is being created?
Yes.
Do you already know how many questions it is?
Well, I'm up to 15, but I think I need a couple more. Need a couple more. Yeah, so I always assume that if you have like 4 choices, I assume that's worst case scenario. What I'm thinking is that, well, you at least need 30 seconds or a minute to read and interpret each one of them, because there's each one of them has its own select and group by, and you have to try to parse it and says, okay, well, it's not this one, it's not this one, okay, it's this one, right? So I'm guessing that each one of them you need at least 1 minute to try to interpret and either go for it or not. So a 4-point question, I always assume that you need an average 4 minutes to interpret it. So that's the way I think about it. Although sometimes a true false questions, I make it a 2-point, even though I don't think you'll need two whole minutes to decide whether something's true or not. So I think it averages out that some of them will be over time and some of them might be a little, the more challenging ones you'll have maybe less time, but hopefully it evens out. Also, I would probably give you this, some trivial questions with the same 4 options. Probably you won't need the full 4 minutes for the trivial ones, even though I give you the same 4 points, which my intention is that you should be able to do that maybe in less time, or maybe have the time, which you can then apply to the more challenging ones. Yes.
Is there a way to
I don't think so. I don't know. I don't think so. No. All right. Anything else? All right. Excellent. Thank you. And good luck Friday.
Friday is waiting at this possible 9, so gonna give the exam online only.
Yeah, I'll have the exam online. Now you shouldn't. So the college really wants folks to be here, so you should have a good reason why not. Health or family or whatever.
Like he's all like he's back in this country.
Yeah, no, yeah, I'm sure there's folks that which is totally fine.
Oh, that's because this process is hybrid also. So.
Yeah. Okay. So if hungry, then it's fine. Yeah.
That's what I was asking.
Yeah. I'll start up the stream.
Yeah.
Same
Okay.
time, just like,
All
like
over.
so. Yeah.
All right. Thank you.
All right.
I seem like whatever.
Yeah, sure. Yeah. All right.
I thought, okay, so I thought it should be RS at RS1. But if it doesn't, like, how does it know to take RS1 from RS to RS1? Because the correct answer is just RS1. Like, how would it know to take it from RS?
So which was it?
This is the last question. I don't know. I think there's a magnet.
Oh, okay. And select the answer, blah, 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 blah. And this is as this, comma.
Like, I think this should be kp.kp2, but it's not. I mean, it's already in there, so I can't change it.
Comma. Oh, from, okay. I was looking for the from.
Okay.
Okay, RS and KP. Yeah, so if the name is unique, right, you don't need to put RS in front of it, right? You don't need to put the name of the table.
So, okay.
So if it's not,
If there's no column in RSKP, that's called RS1.
yes,
Okay.
right.
Okay.
Yeah.
But is it incorrect though, if you do?
No.
Okay.
So what did you put?
I put that and then it says that's the correct answer.
RS1. Yeah, so I can give you that.
Okay. All right. I'll pause again. Thank
Yeah.
you.
All right.
I was working on this before class.
Mhm.
I have a lot of problems trying to MySQL's error notes.
Oh,
Like, I
okay.
feel like it's never enough information.
So yeah, here you probably need to give it a size. Like in parentheses, you'll need, so
okay.
parentheses 4 or something, or like
All right.
that.
Okay, do you have any like pointers for how to figure stuff out like that?
I usually look it up like that and just
Oh,
literally
okay, so
copy
go there.
error code 1084 something on the web. It'll tell me exactly what it
Okay.
was.
All right, thank you.
Yeah.